Hey guys, welcome to MathSpellBook. I'm your host Peter, and basically we are going to get back into electromagnetism today. So hopefully you guys are doing well today. It is Wednesday, so finally the middle of the week is here, and probably you guys are already back in school already, like if you guys are going back to university at the current moment. Or if you're basically already working, you're already like working your day job, that's also another thing. We did this problem already, so let's take a look. Probably get the problem muscles working. There we go. I was like, okay. Let's allow this here. So what's the problem today? Hopefully I think I copied all of it. Okay. All right, let's get started, shall we? Let's see, two equal positive charges, Q1 and Q2 equaling, okay, so luckily we did problems like, luckily we did conversions yesterday, so 2.10 coulombs are located at, so I'm guessing X1 as and Y1 is at this location here. Okay, they reduced it to meters, so we don't have to worry about converting. At Y2 negative respectively. Okay, so might as well draw a picture. So we'll just put Q2 over here and Q1 over here. Alright, respectively, what are the magnitude and direction of the total electric force that Q1 exerts onto the third charge? Okay, so we're given a third charge. Oh, we should probably just put that as big Q, which is 4.010 to the negative coulombs. And this location, we'll put it X3. So it's probably like somewhere around, just put it right here, so this is Q. Alright, so what are the magnitude and direction of the total electric force that Q1? Okay. Alright, so the force, oh, we also need K, I forgot about K, oops. K, 9.010 to the 10 to the 9th newtons per meter squared, coulomb squared. I mean, hopefully I remember that right, but it feels like that is right. Okay, so we need to calculate the magnitude of the force and then the direction. Alright, so we have to do this individually. So K to Q1, Q radius not radius, but distance squared, and then Q2. All right, so now we have to figure out how to actually do like get the direction or the distance actually. Because the distance here we got is basically, I mean, we could use the Pythagorean theorem because it seems like it's a perfect triangle at that point, because it's like got it like right here, and then we got it right here. So I think we can probably just get the distance by doing the Pythagorean theorem for both. So I think for R, because it's very symmetric to each other, so I think R will be fitting in both cases. So we can use x3 and then plus, we can write 2, but the distance is practically going to be the same because it's going to be symmetrical. So put y1 and then y2 on this side. Alright, so R itself, if we do the calculations, so we got 4. So squared plus so that leaves us with a half distance on both sides for the hypotenuse there. Alright. Now so now I think we can just do the calculations here. So for F, so 0.9 times 10 to the 9th times, I think it was 2.0 times 10 to the negative 8 times 4.10 to the negative times 10 to the negative 8, and then divide that by a half squared. That would be 2.9 times 10 to the 5th. That's in newtons. Then plus same calculation. They have the same charge, right? Yeah, they have the same charges. So I want to make sure that it's the exact same number, because if it isn't, because I think it's supposed to be. Yeah, I think it's supposed to be the same number, so we just, so that's 2.9 times 10 to the 5th newtons. And the force altogether magnitude. What is the direction of the total electric force? Well, it's gonna repel, so because they're all like charges, they're all positive. So now I think we can do like so we can just do tangent, because we can just get the angle, and I think the angle will tell us the direction of the force. If we do and we just have to take the negative for the other one, for the charge 2, so that turns out to be 36.9 degrees, and the other one will be minus 36.9 degrees. And those are the directions. Excuse me, sorry. I mean, hopefully this is what we're looking for. I think in math and physics they switch them around. Okay, so 5.5 and 36.9 degrees. So let's see what we got here. A step somewhere? This is the right number. Oh, it's minus the 6. Oh, I did nanos. I did nano. I think that's the reason. Because I was thinking of, I forgot, like, I think I did nano coulombs by accident. It's supposed to be micro. So that was, so I screwed up there. It's supposed to be 6. Okay. Now, so I think we got to do the math again. So we have 9.0 times, and to the -6, and 4.10 to the -6, and then divide that by there we go. So it's supposed to be okay, so that's why my numbers were off. It was way less than I should have done that. And we're left with let's see. Let's see. For the symmetry, we see that the two forces X component. Let's see, the total force of Q neither is directly away from Q. Rather, this direction is the compromise that the point away from the system charges. You can see that the total were not equal, or if the geometric arrangement of the change were not so symmetric. So let's see, the X component of the forces, 3 newtons. So the total force on Q is in the positive X direction with a magnitude of this is correct. So these out. Okay, so that's for the X. And for the Y, let's take a look here. So why is it that they took the X component of this one? So the setup must compute vector sum. Equal. So this is the force in total. Now the X components of the two forces are equal. From symmetry, we can see that the Y components of the two forces are equal and opposite. Hence their sum is 0. Okay. See, the Y components of the two forces are equal and opposite. Oh, I think it's because of this right here. So if that's the case, if they're perfectly symmetric, it's not going to affect this. This is like one of the forces. So this is the force here, and then you have to add these forces together. Okay, so I think what I missed was this part. Because it's asking for the magnitude and direction. So we got the magnitude. Go into electric fields. I'll be right back, guys. Give me 1 second. Okay guys, I'm back. Hey Sascha, how's it going? Doing alright. Did a misstep on the problem we did before, but you know, that's part of basically learning physics. Sometimes you have to learn from your mistakes. But what's the best part of your day so far, Sascha? So here we go. Electric fields. Goody. The electric force, let's see. Hold on, I want to reread this again. Let's see, from the symmetry we see that the y components of the two forces are equal and opposite. So oh, maybe it's like, I think in this part it's sort of like a linear algebra type of thing, where it's like the systems of equations, so they probably cross each other out. If you line up both equations of the forces together, it's probably why they're 0. Makes sense. Okay, now it makes more sense now, because I was like, why is it that the y component is 0? And I'm like, oh wait, no, they're like, I know they're equal, but at the same time, like, when did they cross out? And I'm like, oh wait, hold on. If you're thinking in like a system of linear equations, or yeah, something like that, like they would cross out. Okay, that makes more sense. Had 3 courses. Oh wow, what courses are they? And how does it feel to like start your PhD program? I met with a potential new PhD advisor. He's such a cool dude. Oh, nice, nice. Didn't you also tell me that your advisor was also a Nobel Prize laureate? Big honor if they are. Well, you said he, so I'm guessing it's a man. Because when you told me that, I'm like, oh, maybe I should try to look up this potential person. Functional analysis, geometric geometry, differential topology. Oh, okay. I thought you weren't really into functional analysis. But I guess it's involved with your field, so you might as well take it, right? Because I remember I was asking you about functional analysis, and you're like, why do you want to learn that? Or something like that. I think you were just kind of surprised that I was asking about that, or like actually like download a book about it. Let's see. The electric force on a changed body is exerted by the electric field changed by another charged body. There are some at my university who got the Nobel Prize. Oh, okay. Nobel Prize in physics. Oh, okay. I see. Let's see. So, electric force on a charged body is exerted by the electric field created by another charged body. To find out experimentally whether there is an electric field at a particular point, we place a small charged body, which we call the test charge, at point, where is that? Oh, 15C. Set up an electric charge. And this is the electric field. E is the force per unit charge exerted by A in Tesla. Okay. I mean, but how are your courses though, Sascha? How is functional analysis, and how was algebraic geometry and differential topology? How are those courses? Let's see. Okay, what is this? If the test charge experiences an electric force, then there is an electric field at that point. This field is produced by charges other than Q naught. I will probably drop differential topology if I was the if I passed the qual exam in that subject. Oh, okay. Wait, if you pass it, then does that mean you just know everything? You already know the stuff that is involved with that course already, so you don't have to take it? Is that what you mean? force vector is a force is a vector quantity, so electric field is also a vector quantity. Note the use of vector signs as well as boldface letters, and plus and minus are equal signs. We define electric field as E at a point as the electric field force experienced by a test charge Q naught at that point. If you pass that exam, does that mean you just know, it shows that you know everything within differential topology? Is that what you mean by like dropping it? So divided by the charge Q naught, that is that the electric field at a certain point is equal to the electric force per unit charge experienced by the charge at that point. Ooh. Well, I get the credit for that course, for that class. Yeah, that's what I mean. Like, you basically just pass an exam that basically says, hey, I know everything about this course, so I don't need to take it. But you still get the credits because it's like you already passed the course already. Because you already know the material that's already in there. Like, that's what I meant. Okay, so we got a new equation. An electric field. Force. Okay, let's see. Force of gravity. We got a mass and then the acceleration. Okay, so I guess we're gonna have to think of like the electric field as basically like instead of F equals ma, we think of it as like well, like for the force of gravity, you would have to think of it as mass times g, right? So for this one, you would have to think as the Q naught times the electric field, which is honestly, when I think about it, it's like it's somewhat similar, but at the same time, it's kind of like newish because like well then again, like the acceleration due to gravity, it's even though it's a vector, like you can kind of like quote unquote, I guess, think of it as like in a gravitational field in some way. In some way, but it's just, but I mean they're both vector quantities. It's just that I guess because I'm thinking, because the electric field is kind of like a field, I think of it as a field. I'm like, but then again, like the acceleration due to gravity is also a vector, and in this case it looks like the electric field is considered a vector, quote unquote. So I guess it's sort of similar in a way when you think about it. So I guess the similarities between gravity and electricity are kind of like similar when it comes to like fields, but I never really thought of like, you know, the gravitation, like the Earth's gravitational constant is sort of like a gravitational field, but I guess it can be considered a gravitational field if you think about it deeply. Okay, here we go. Oh, okay, so this is the electric field at a point charge. Okay, so oh, I forgot to actually remember what this one is. I know that has to do with elasticity, right? What is epsilon? Or epsilon naught? What is that? Epsilon naught. Because I forgot what the name of that is. I mean, like, are you gaining some like new insight through your functional analysis course, Sascha? Like, what stuff did you learn from there? and hopefully it benefits your research if it does. Or at least like what ideas you have for your PhD, like possible PhD thesis, if you're going to develop it from there. So we can think of this as 9, well, 8 point, we can think of it as 8.9 times 10 to the negative 12. Because this one is, we can think of it as 9 to the, this one's like 8.9. Think of like 8.9 to the negative 12. I mean, we could round it to 9, but I feel like that might be overstating it. Because sometimes when you study, guys, like, sometimes putting a little excerpt, like, from what you read is also kind of, like, beneficial. Because then it makes your brain kind of, like, exercise exactly, like, what exactly you should pay attention to. Okay, now we're getting into vector fields. So this is the electric field on a charge. The field produces by a negative charge. Charge points towards the charge. So now I'm thinking about, what do you call it? I'm thinking about, divergence. Now I'm thinking about divergence and stuff. Okay, so we got a problem here, so let's just get our feet wet with this. Okay. So what is the magnitude of the electric field at 0.2 meters? Okay, so we have two equations. We have the electric field is equal to the force over the charge, and we also have like the Coulomb's equation, or the Coulomb's law, I should say. Charge 1, charge 2, radius, which is also equal to 4 pi epsilon naught. I just want to write these down so I know that I have them in my arsenal. Okay, I'm surprised I actually remember that. Oh yeah, and also the electric charge is this formula, so probably should write that down too. So electric charge is equal to 1 over 4 pi epsilon naught, and then the charge over the radius squared, right? Yeah, radius squared. And then there's our hat there. Alright. By definition, the electric field of the point charge always points away from the positive charge. That is in the same direction as r hat. But towards the negative charge, that is the direction of the opposite of r hat. So I'm guessing like whenever we do a negative charge, we have to put a negative sign in front. Yeah, I think that makes sense, because like when we have a negative charge, it just basically gives us I guess like a positive result on how much force there is, like on the negative charge. So we have a charge that is, okay, so the R is 2.0 meters, and we have a charge that is 4 times 10 to the negative 8, because this is nano coulombs. I got the problem wrong last time because I thought it was, I mistake micro coulombs with nano coulombs, which can happen. Alright, so I think we have to revolve this formula. So if I remember, epsilon naught, because we just went over that, is 8 point, I think we'll put 8.9 times 10 to the negative 12 coulombs over Newton's, oh no, not Newton's squared, Newton's meters squared. Okay, So I think now it's just basically just putting the numbers in. So we have 1 times 4 pi times 8.9 times 10 to the negative 12. Then that multiplied by the charge, which is 4.0 times 10 to the negative 8 divided by 2. Wait. So we got an electric charge of 89.40, and this is, oops. So if we do the units, we got coulombs, meters squared, and on this side we have so if it's on the bottom, then it's going to flip over, so it's going to be meters squared, coulombs squared. So then we cross these two out, this goes away, and this one gets reduced, so it's newtons per coulomb. Now, is there... Oh, hello, Titan. Welcome, welcome to the YouTube Live, the YouTube live stream. Use for epsilon naught. Does it really matter? Actually, yeah. Because let me take a look. Because it says K is equal to. It's better to make sure though. Yeah, because it says that 1 over K is. I'm from the US. Where are you from, Titan, if you don't mind me asking? And if you don't want to reveal that, that's fine. Just basically say, oh, I just want to remain anonymous. That's fine. I mean, it's practically the same if you put K, but then again, but we do have it over a fraction, so I think that should be. I mean, when you do it this way, I mean, yeah, you can just use K. That could also be an option. India? Okay. Actually, 1 over 4 pi epsilon is not a constant. Oh, okay. So, why is it that they put in the book that it's like equal to K though? I thought it was just another way to get K. That's the reason why they give you that formula. Unless there's a certain situation when you have to use this this number. I'm just thinking you use it when you only know epsilon naught. But then again, epsilon naught is a constant itself, so... where were we? Oh yeah, right here. Okay. Alright. It makes it simpler to solve the questions. Oh, okay. So let me just check what I'm actually gonna try to see if I can follow your advice there. So I'm just gonna make it 9 times 10 to the 9. I forgot to put that in parentheses. Times the charge. So we have times technically 4. I mean, that leads us to 90. So, I mean, they're practically close. Doing it with K and doing it without. Epsilon naught is for vacuum. Oh, okay. Alright, if you say so. I guess we're gonna have to... I'll go with what you suggested. I mean, the difference is not that huge, but I can see what you mean, though. It makes the numbers easier to deal with, actually. So, let's take a look and see if we were correct. So, we'll just square that so we don't forget. Okay, so take a look. Yep, there we go. I mean, yeah, it's practically the same value. Yeah, so we got that right. Okay, cool. Because that seemed like a simple problem to do. It's just plugging the numbers in. In different mediums, we get different epsilons, therefore different values of K. Okay. I see. That sounds like the higher you go, the more advanced it gets. Okay, that makes sense. Oh, we got another one. Cool. I love it when they just put question after question, test our skills more. Now, does this rely on the previous problem? No, it doesn't. Okay, so let's take a look. All right, so we got a point charge. Q is equal to negative nanocoulombs, so negative 8 times 10 to the negative 8 coulombs. Is located at the origin, so x and y are 0. Find the electric field vector at the field at the point. Okay, so we'll just put naughts here. Meters y. Okay, so we're actually, to make this more fun, we could probably make it like this. Plus, no, it should be minus. Oops, no, that's not y. It should be j. There we go. We'll just put we'll put s for position. This is the vector equation for the position we want. No, I am not. I'm actually way past high school. I'm literally like 35. So I'm just basically doing physics, studying physics like for my own hobby. It's basically a hobby of mine to basically study this and to do it in front of you guys, do it on stream. So I'm basically learning physics on my own, along with mathematics. So I'm not really a teacher or anyone qualified like in that sort of thing. I just like doing this stuff because it makes me feel like I'm learning more about the world. What about you, Titan? Are you currently in school right now? Okay, so let's write the equations that we can use. So electric field is the force over the charge, not, but it can also be epsilon charge over the distance radius, but it can also be written as K, just like Titan suggested, so we can make the math easier. Just to keep that in mind. Okay. I'm in a gap year of school preparing for med school. Oh, nice. Med school is tough, though. I don't think I would be able to do what doctors do. For me, it's like, I would probably like to read about the human body, but to like learn like a phone book on how it works, I'd be like, maybe maybe I'll probably read on my spare time, but not for like a grade and a medical exam. I mean, med students, like, they're on a whole nother level than on their own. Okay. Okay, find the electric field vector at the field point. Okay, so it's from the origin, so if we draw this, so that, oops, I forgot I didn't have my pencil out. So the charge is at the origin, Q, and then from, let's make this 1, and then like 1, 2, and then we have negative 1, 6, so it's like 1, 2, 3, this is negative 1, and this is positive 1, and then if we go 1, 2, 1, 2, 3, 4, 5, 6, so we got to go down here like so. So we got to know what the force is on here. Okay, it's like more frustrating. Yeah, I mean, like, it's a lot of pressure though, because you have to know a lot about the human body, you have to read a lot of books, and you also have to make sure that what you read you have to experience on how your, I guess, the techniques that you employ from like the book to your own methodology is like working with your experience. And like, you know, because like the potentiality of like something happening to a patient is like pretty high, because you don't know what the patient may have, or like the conditions they may have, and or their body. You don't know if it's going to react well with the standard procedure, so you might have to make adjustments. So it's like all that stuff is like, I don't know like how doctors or nurses handle that. I'm like, wow, that's like a lot of stuff. Me, I'd rather be just like on a blackboard, like just like, you know, if people were like, could you teach me like Calc 2 or Calculus 1? And I'm like, I can do Calc 1. I have to really brush up on Calc 2 though. Yeah, I don't like my standard education, I would have to say, is that I did take linear algebra online, but I felt like I didn't really learn the material solidly until I started learning linear algebra on my own. But I still have to master like the stuff in the later parts of linear algebra. Like I did do some eigenvalue problems a while back, but I'm starting to realize that I'm starting to forget how to solve those. So I have to actually like catch up on like the math that I kind of missed. I mean, at least I know how to do matrix multiplication. So now we gotta find the electric field vector. So I'm guessing R here is probably gonna be the it's gonna be our distance, but we're gonna have to get the distance, like, I think this is gonna be R here, so I think that's the thing we're gonna have to figure out. So we got the charge, which is good, and we know we have to multiply by k. So I think the last thing we have to do is basically do the distance. So the distance we're gonna have to do is, luckily it's at the origin, so it's not too big a deal. Okay. Alright. Unfortunately, I don't have my calculator in front of me. I mean, on screen for you guys to see, but I'm doing it off, like, I'm doing it within my hands right now, so let's do the calculation. Wow. Simple too. Awesome. So we don't have to do any fidgeting around. Okay, now we'll do the easy part. Well, I probably shouldn't say easy part, but like, you know, now to do the calculation. Okay, here goes. We'll just go with what Titan suggested we do. We just basically just put k in. 9.0 times 10 to the 9th power times negative 8 0.0 times 10 to the negative 8 power, and then do that, and then divide by 2 squared, which is basically 4. So we have a negative charge. So if we have a negative charge, then we have to make, I think, R negative. So therefore we're left with, and let me make sure that I got the units right. So K is basically K is in meters squared, coulomb squared, and the charge we have for coulombs and meters squared. So these will cross out, this will cross out, and then newtons per coulomb. Okay, I think we did everything right there. I mean, everything looks fine as long as we use the right expression. So what do we got here? Find the electric field. Oh, the field vector. Oops. Well, I got the strength of the electric field. So I guess we're gonna have to do this. What was I thinking? Oh yeah, right. So I have to figure out what the angle is. So okay, tangent. So y is at the bottom, like y is at the top, so we don't have to worry about multiplying by 180. I remember when I was learning about like so the angle negative 8 to the 10 to the 9th power, not negative 8. I remember I did it negative to the 8th with the last stream, and the answer was correct. I mean, I did Google it, so because on Google it basically I basically saw the number formation. But then again, oh wait, was I working with 25? Yeah, I was working for single digits. Yeah, I mean, I was working for double digits. I think that probably might be it. So yeah, you might be right. So that changes things. So let's erase this for now because it's going to distract me, because I think we're going to have to recalculate. Okay, so all right, so now we'll do this again. So dot to the positive, and then we'll do it so negative 8.0 times 10 to the negative 9, and enter, and then divide that by 4. So that leaves us with like 18 newtons per coulomb. Okay, so now we got to figure out the angle. So tangent negative 1.6 over 1.2, that's negative . I always remember when vectors are at 90 degrees, their resultant will be 73 degrees from x to 53 from y. Oh, okay. I mean, at least you're able to remember that. For me, I usually just do with the simple 10, like 10 by 10. Like remember that 90 degrees is like usually like, you know, 90 degrees and all that, but that makes sense because I think a radian is like not even because I think a radian is only like 50 something. Okay, so now we can do the vectors. So 18 cosine of negative 53I plus 18 sine of negative 53. J. That this is a vector problem, so it's like 10.8i plus 18 sine negative 53.1, so that's negative 14, negative 14.3 I. Okay, is that close to negative 11 and 14? Point, so y is negative here. Why did they put negative 11? Is that because the... since Q is negative at the point, the field charge, the direction is opposite. Let's compare. Oh yeah, that's right, because it's a negative charge. So it's basically the charge is supposed to come towards that, so if you multiply maybe that's why. So maybe this is what it means. Okay, so maybe that's why, because we have to put the negative in front of this. I mean, that makes more sense though. It is 3:06 p.m. in my side of the world. What about you, Titan? What time is it on your side of the world? I don't know why I'm saying world like that. I think it's because I think it's just like whenever I hear people say world, it always sounds different in different accents. And it's fun. So let's just I want to read this so I can be very clear about it. So since Q is negative, the E points from the field point to the charge and the source of the charge in the direction opposite of R, compared to 17. Where is it? Oh, here it is. Oh no, that's 18. Oh, here it is, right here. So we leave the calculation of magnitude of the direction you see. So okay. Alright, so whenever it's negative, we have to remember we have to multiply everything by a negative sign at the end. So that's a good thing to know. Oh, we're getting a lot of examples today. And I think we gotta do this too, because it's saying a figure. Yeah, I usually like doing the examples from the textbook because it's like, oh, oops. go. Alright. When the terminals of a battery are connected to two parallel conducting plates with a small gap between them, the resulting charges on the plates produce a nearly uniform electric field E between the plates. In the next section, we'll see why this is. If the plates are 1.0 centimeters apart, okay, so let's just 1 centimeters, which in turn would probably be 1/100 meters, and are connected to 100 volt battery is shown. Okay, so we got voltage, so 100 volts battery as shown in the figure. The field is vertically upward, has a magnitude. Oh, there's more to the question. Oh, it's right here. Okay. All right. Paste it right here. And can we line it up? Nice. Dang, I was so close to actually lining it up perfectly, but you know. There's a different formula for this one. You'll have to derive this one. Probably. Let's see. Oh, here we go. So we got E. E is 1.0010 to the fourth newtons coulomb. If the charge E is -9 coulomb and the mass is 19.11 -31 kilograms to release the upper plate. What is its acceleration? Oh, okay. This is a very intricate question. B, what is the speed and the kinetic energy? Does it acquire while traveling 1.0 centimeters to the lower plate? How long does it take to travel this distance? Ooh, doozy. This one's a doozy one. Oh, we got, let's see, the diagram here. So at least with the diagram, we don't have to draw the picture. Okay. Alright, so I think we should just write our equations out. So we have E is equal to KQR, or we can just write this out just in case if we need it, so we can see like possible relationships. Okay. So I guess E will be treated as our Q in this case, but they gave us mass, so what is an equation that has to do with mass besides force? I think I remember there was one equation that involved mass. Not that one. If not, oh, maybe the force is, maybe the mass is meant to help us get the force. Maybe that's why. I mean the acceleration, because it asks for the acceleration of the system. Okay. So basically, I think we have everything we need practically. Because we have this, and okay, so question is, I think it's basically we calculate the force. So we have to get the force here. Because the force of the electric interaction, that's Coulomb's law. So just in case if we need it, we'll just write it down here. Because I think that's what we need, because we need the actual force, and then we can take away the mass, and then we can get the acceleration. So, oops. So force equals ma. There are two charges on the so there will be two electric fields. Let me see. Let me reread the question. So let's see. The plates are one centimeter apart. The field is vertically upward and has a magnitude of. Okay, so this one has a magnitude of. Okay. If the electric charge, or if an electron charge is released from rest at the upper plate, what is the acceleration? Okay. So the negative charge is going to go to the positive charge on the bottom plate. What is the speed and the kinetic energy does it acquire while traveling? 1.0 centimeters to the lower plate. How long does it take to travel? Okay. All right. So 100-volt battery. This one. So this is only for the upper. The field vertically upward has a, yeah, okay, so this one has the electric field of this. All right. Now kinetic energy is equal to the charge multiplied by the magnitude of the electric field. I'm just like letting myself struggle. Like I wouldn't maybe struggle is the right word. It's not like I don't know what to do. It's just that for me, it's like I feel like I'm trying to develop the starting point, and I think that's basically what I'm thinking about right now. That's why, because like I'm thinking about what we have available to us, and I'm also thinking about how the system is like working. So that's why it's like seems like I'm kind of like taking my time with it. No, it's okay. It happens. That's why, like, you know, when I read what you type up Titan, I'm like thinking about it, but at the same time, I'm also thinking about where is the path that I need to go to individualistically in my head to basically make it make sense to me, you know? Because, like, I know a lot of people, like, some people, like, they can think at a different speed, and then they see, like, the ability, like, they see possibilities on, like, what they should go for. So for me, I'm just trying to find my way into the problem. So, that's why sometimes when I do problems, it seems like I take, like, maybe, like, a couple minutes or, like, a couple seconds to actually, like, ruminate on it. Force is equal to the charge multiplied magnitude of the electric field. Yeah, because oh yeah, like, I probably should also write this too. I almost forgot that. So force is equal to, so we know the electric field, so that means that force itself, oops, that actually makes it a little bit easier, I think, because then we know that Q, the charge, into the electric field. So, okay, so we got the force, so that means now we can actually get the acceleration, I think. So I think that's gonna actually help us, I think. So now we found our way in. So now we gotta calculate the force. This is gonna be fun. So we gotta charge. Wait, does the... Hold on, I have to look this up. Does the electric field equation have an R hat? No, it doesn't. Okay. That makes it much easier for us. Okay. So, we have a charge of negative 1.6. No. Parentheses first. Parentheses. We have a charge of 1.60 times 10 to the negative 9 coulombs times 1.00 times 10 to the 4th power. Dot. We have negative 10 to the 5th newtons. Okay. Okay, now we do F equals ma, but then we have the mass of the electron, so all we have to do is basically do this. Hope so. Hopefully. Okay, so divide that by 9.11 times 10 to the negative 31. Oops. My calculator didn't take into account that I want to make it an exponent. Okay. Here we go. Negative 1.76 times 10 to the 25 meters per second squared. Is that right? Huh. Let me do that number again. Maybe I typed the numbers in wrong. I think I typed the wrong numbers, maybe, because it's like 1.6. So let's erase that for now, because I feel like I might have made a mistake here. I just want to make sure, because I felt like I might have typed in the wrong numbers, just in case. So divide that by 9.10 to the negative 31. Oh no, it looks like that is the right numbers. I mean, it doesn't have much mass, but that's very fast. That's very fast. I mean, then again, it's like negative. I mean, it is a negative charge. I think we have to make it positive. So I think if it's positive, then it was a... Because, I mean, it is negative, so you have to multiply it by then. So I think it's supposed to be a positive number. But we can definitely check it, because, I mean, I feel like that's the right approach, because they wouldn't have given you the mass and stuff otherwise. Alright, let's take a look. The thing about, like, physics is that, how should I say? Sometimes you have to, like, fummage through the math to basically see what exactly you should be seeing in the problem. And I think that's basically what I've been doing. Oh, do we have to write as a vector? Oh, I think there's many parts to the question. I probably didn't look at it. I got the acceleration right, so we got the acceleration right. So let me just take a look here how they did it. Okay, so you leave it negative. Okay. Okay, so I wasn't bugging out on that. Okay. But luckily I'm developing the muscle of questioning the numbers. No, I don't watch football. And yes, I mean football as in soccer. Actually, honestly, I like, as an American, I kind of find it weird that we call football football. In my personal opinion, like, I know like a lot of Americans would probably like hate me by saying this, but I'd rather call it American rugby. Because that's practically what it kind of is, but I don't know why they call it football. I guess it's because you just kick the ball during the open kickoff or something. I don't know. But I'm not into sports, so like if anyone likes sports, like, you know, please don't hate me for like making that remark. Okay, so we got so we got the acceleration. Now, what is the speed and the kinetic energy does it acquire while traveling to okay, so if I remember correctly, kinetic energy is... Sometimes, like, when I see kinetic energy, they write with T or they write it with K. And I always get confused whenever they do that. I mean, do you... I'm guessing since you asked, you probably are into football, right? Titan? When I say football, I mean soccer. Excuse me, for my American audiences out there. So we got that. So, So what is the speed of what's the speed and the kinetic energy required in the lower plane? So now we have to actually get the velocity. So since we have the I mean, I do like learning Japanese, anime, reading manga, like watching TV shows. Like I have some like my interests are like pretty minor. They're pretty like boring. I usually like reading. I like to read. Like, I've been reading a little bit about chemistry. I mean, so far, like with chemistry, I'm still learning the periodic table. I think I kind of memorized the first two periods. So, like, you know, hydrogen, helium, lithium, beryllium, boron, carbon. After carbon, there's nitrogen, oxygen, fluorine, and neon. And then after that, then there's the second period, the third period, which is sodium, manganese. I think it's manganese. And then there's aluminum, silicon, phosphorus, sulfur, chlorine, and argon. I think. I think those are the ones. I just asked because Messi plays in the US. Oh, okay. Let's go. What's your favorite manga? Manga. I would have to say it's Detective Conan. Like, Detective Conan is probably my favorite because with manga, I really like, I read like basic, like, you know, manga that nobody hears about. Like, you know, I guess it's either manga of like anime that's already released, or like I read like a lot of like romance and a lot of like, I would have to say, trashy manga. I don't read like the most mainstream stuff. That's how simple I am, I guess. I don't read like shonen that much, except for like, you know, more like it depends on the shonen actually, because I get tired of like watching characters fight all the time, like with fist to fist. I mostly like reading intellectual games like Death Note and all that. Oh yeah, so we have to... Okay, so we have to figure out the speed. Okay, so what is the speed and the kinetic energy? So we got the acceleration, so that I think the acceleration is supposed to lead us to getting the speed. So I think so we have to think about the kinetic formulas. Oops, no, I don't want to do that. So kinetic formulas, so I mean, I might as well write them down because there's only 3 of them. So I think we're probably gonna maybe use this one, but we don't have time, so we might have to use the last one. Times 2 to the acceleration and the distance. Okay, so I think we're gonna probably use this one. Because I think the initial velocity is 0, so we don't have to worry about the initial velocity. Okay, let's do this. So the acceleration is 0, I mean, it's negative, so I'm guessing we're gonna have to do -1, no, we're gonna have to do -1/100 meters, because it's centimeters. Oops. And we already know the acceleration, so that should give us a positive number to work with. So, okay, now I'm gonna type. Magnesium. Magnesium, yeah, it's not manganese. I mean, I'm getting close to like memorizing them. I didn't say I was good at it. Like, I like the other ones, in the periodic table. I'm gonna have a harder time trying to memorize those. Shonen is low-key boring, except One Piece though. I tried to get into One Piece. Like, I tried watching the anime 3 times, and I just got bored by episode 3. And I'm like, I really tried, guys. I want to like it, but I'm like, the only One Piece that I guess I can watch is the live-action version they're making on Netflix. I know it's not gonna follow the anime 100%, but I'm like, that's the only one I can sit through and watch. I really tried to get into One Piece, I really did. Okay, so the velocity is 5.92 times 10 to the 11th meters per second. Very fast. So we already have the mass, so now we can get the kinetic energy. So we got this. Now for the kinetic energy. I think the mass was 11 point, and I think 10 to the -31 kilograms. Is that it? Go back. Yep, I was right. Okay, cool. My memory is not failing me. So half times 9.11 negative 31 times the velocity of, we can just basically just plug this in, squared. So, wow. So the kinetic energy is 1.59 times 10 to the -7 joules. Okay, so is there a C we have to solve for? Okay, how long does it take to travel this distance? Okay, so we got the final velocity, and we got, okay, so now we can do the kinetic equation for the time. So this one should be much easier to handle. So time is equal to the final velocity over acceleration. Okay. Now, there's something in me that's like, I probably should make the velocity negative because the acceleration is negative already. And technically it is negative because it's going down, because I think the diagram here is that, yeah, it's going down instead of going up. So I think it's valid that we can make the velocity negative, I think. Because that's the thing about physics, that's the thing that kind of, I guess people can say that math is not physics, because the math doesn't tell you when to, I guess, when to make things negative, because that's when the experiments come in. So you actually have to make those interpretations on your own. I think that's like one of the things that people can win on the argument that physics is not mathematics. But at the same time, like, you know, it's like very mathematically concise, which I think is also very cool. What was the acceleration again? Okay, so 1.75 times 10 to the 25th. Oh. For some reason, I'm not liking that number. Because it says 3.38 times 10 to the negative 14th power. And I feel like that might not be right. Let's see if we got B right first before we go into C. So for B, whoa. The magnitude is way off. What did I do wrong? Wait, 10 to the 15th. Why is this 10 to the 25? Did I make a miscalculation somewhere? Or maybe I miswrote. Let me check my calculations. No, it says 25. Why is it 25? Let me check if I made the conversions wrong. More likely I probably did the conversion wrong. So the force here, we got the charge. Let me see. Maybe I typed in the electric force wrong. So let's just do this over. So 10 to the 4th times the charge, which is negative 6 times negative 9. Yep, that's the right equation for the force. So now we'll divide that by the mass. So the mass is 11 10 to the negative 31. Yeah, it gives us like 1.75 times 10 to the 25th power. Let me see. Lord of the Rings or versus Harry Potter? I like both, honestly. I think I would probably be more leaning towards more of a Harry Potter fan, but at the same time, if you were to ask me honestly, like what I would prefer, I would probably like pick like the hardest question to ask me is like Harry Potter versus Doctor Who, and I probably would pick Doctor Who over Harry Potter at that point. Okay, what was off about my calculation? Because I plugged in the numbers right. So why is it that I got 20? Did I misread a number? Because this one says 1015. And it's like we get the digits right, it's just that we don't give the order of magnitude right. Something is pretty iffy. Because this one is, I think, 38 times 10 to the negative 14 seconds. Yeah, like my numbers are like, and I don't think we have anything missing in the, did they put the wrong numbers in the answers? Or is it that I'm doing the math wrong? I mean, I usually associate that I'm doing the math wrong, but because I think we did the right numbers. Oh wait, hold on. 1 points. Negative 19. Negative 19? They put one. Oh. Yeah, I think they made a mistake here. Or maybe I made a mistake on what the mass is. I mean, what the charge is. Because this one they put one negative 19 here. Because in our problem, it says 9, unless I misread that. Nope, it says like negative 10 to the 9. Sure. I'm not one for giving advice, but I can give you, like, I guess my point of view on what is it that you want to talk about. Yeah, I think basically some of the numbers are mixed up in this problem. But luckily we saw it because, like, I think, like, we did everything right. Because, like, the numbers are correct. It's just that the orders of magnitude are kind of, like, off. At least I was able to observe that, so I guess I'm kind of proud of myself to see that. And the best part is that I kind of came to this formulation, like at least like I mean with your guys' help too. Like I came to this formulation like just thinking deeper about the problem. So you know, let's give ourselves a pat in the back. If I don't crack a good college, would my life? No, I don't think so. Because the thing of it is that, like, I know, like, you know, with different schools, there's, like, different ways of prestige. Because, like Titan, do you mind if I ask how old you are? Like, how old are you? Like, are you in high school, I'm guessing? Or are you in undergrad and university and you're just trying to enroll in a good med school after you finish university? Okay, electric field calculations. Ooh, I think this one's... Oh, you're 18. Okay, so you're about to start university or... Yeah, because I think... Because I don't know how it is in India, because, like... Because in my point of view, I think whatever school you do, it doesn't really matter because you're still getting the same knowledge. Our high school is over by 16. Oh, okay. I don't think you should think of your school as like something that makes you feel like you're destined to fail for life if you pick the wrong one, because a lot of teenagers feel that way. But you're already 18, so you're already old enough to like, I don't know what the voting age is in India, but like in the US you would be considered like already like an adult, about to like, you know, make your decisions about going to school, going to like university and stuff. So I don't know how it is in India, like I said. So I don't know if you can just go straight to med school, or you have to go through university and then go to med school. Like, do you mind if I ask you that? Like, because you said you want to go to med school, right? If you want to go to med school, that's fine. Because like, I give you a pat on the back for like having the courage to be a doctor or someone in the medical field. But if like, because sometimes I feel bad for students that just go to med school because they think, because their parents tell them that's the way to go. Because there's a lot of pressure being a doctor, and if you don't want to be a doctor, that's something that I kind of wouldn't want to force my kid to be into. Like, I don't care how much it pays or how much prestige there is. If you're not destined to be a doctor and you don't feel like in your heart that you should be a doctor, then don't be a doctor. That's my personal opinion. You go straight to med school, but the exam is super hard. No, I'm not surprised. I'm not surprised that the exams are going to be super hard. I mean, if you go to med school, sure, there's like, you know, like schools, they may have the prestige and everything, but because they have the prestige, they have higher standards, and it makes it very hard, like much harder than like most other schools. So I would have to say, like, if you can get into one medical school, I think that's an achievement over someone that just can't get into medical school despite how much they've tried. So, you know, I feel like any type of school will teach you the same amount of knowledge. It's just that they don't have that name recognition. And I think, in my personal opinion, if you go to a school that doesn't have much name recognition, or it's still in the field, but they're not very like influential, like, you know, like having higher standards, then I think that's just as fine as saying going to school for like, you know, like those like very famous medical schools, because the famous ones always charge a lot for tuition, because they know that they have the prestige and they can give you the connections to go to like finding a job easier. The schools that are not really recognized, they basically just don't have as much connections, but they still are connected to the medical field. So you probably will likely talk to a professor that has connections within certain hospitals or certain clinics. So, you know, I feel like any type of school is fine. It depends on what you can handle, I think, because with schools that are more renowned, they have higher standards, and sometimes students drop out because they can't handle the standards that the school put into them. So some students, they probably go to one medical school, but then I'm pretty sure there's probably one or two students that are like that. They basically go into one medical school, and then they couldn't handle the standards, so they end up dropping out from that school, but then they went to another one that was not as strict or stringent, and then they managed to pass and graduate from that school if they decide to go back to university. Our education is free if we crack the exam. Okay. So, if it's free, then, you know, like, if you want to get into certain schools, just basically just take exams for, like, the schools you want to go to. And then if you pass any of them, or maybe all of them, you know, you will be getting a call back from them. So, you know, I would say, like, just do your best on the exams to the places that you want to go. And I would have to say have a list of 3 or 5 schools that you want to go to. And then once you're done doing those exams, then just, you know. But I wouldn't say like do exam like after exam. I would say like probably do one exam, and then hopefully you do one exam, and then maybe like the next couple of days, like if they allow you to take an exam for the next school, you basically do that exam for the next school, like probably after a month or probably a few weeks, or whenever they do the exams again, you know. But that's basically what I can say, though. It's not really words of advice, that's just basically something that I would think of doing. Because I know, like, when you're young, they expect you to do a lot of things, but you get so stressed out and burnt out that I think that that's the thing that I don't want to encourage people to do. That's why, like, I stream my studying, because, like, you guys see me when I did things wrong. You guys see me when I make mistakes. And you guys see me, like, basically try to encourage myself to, like, get back up whenever I get a question wrong on, like, whatever thing I'm studying. Even when I'm stuck doing math proofs and I don't know what the heck I'm gonna write, like, I show it to you guys because we're all human beings, and it allows me to see the gaps in my thinking. So, you know, because I know a lot of people on YouTube or in, like, you know, content creators that basically do math or physics. They basically have, like, bachelor's degrees and they can teach the material, but for me it's like, I'm making content because I want to learn this material. And whether, you know, whether people in the math community think that I'm worth watching or not is totally up to them. We don't get to choose med school. We get a lot on basis of rank. Oh, okay. I see. Well, like, yeah, I'm not sure. Like, I don't know if, like, what I'm saying is, like, helping you at all. like, for me, it's like, I'm just saying it based on what I feel is right to say. But like I said, I don't know what it's like in India. Like, but I think, like, the overall point I want to make is that I don't think, like, you know, the wrong school is going to lead you to the wrong path. That's what I mean. Because what the school has is just name recognition. But when you go to different institutions, they basically teach you the same material. The only thing that a school can give you that probably is unique to every individual school is mainly different areas of research that they probably specialize in better in, or they have specialists in those type of areas. Hello, Romaine from Twitch. It's nice to see you in chat. What's the best part of your day so far? First time chat, huh? Hopefully I pronounced your name right. Romaine Dish. That's a pretty cool name. From Twitch. What's the best part of your day so far? Okay, so what do we got here? Okay, yeah, electric field calculations. But hopefully what I said helps you out, Titan. No, you're welcome, Romaine Dish. Okay, so let's see, equation 21.7. 21.7, that's example. Does it say equation or example? Equation, okay. Equation. Oh, Romaine Dish, thank you for the follow, I appreciate it. 21.7. Okay, there it is. Okay, it's that equation. Gives the electric field caused by a single point charge, but in most realistic situations that involves the electric fields and forces we encounter charge that is distributed over space. Okay. Actually, it's kind of cool though, because like, thanks to you guys, whether it be on Twitch or YouTube, like, my follower count is, like, almost matching that of my subscriber count on YouTube, which I'm very happy about. I mean, you know, like, with Twitch, like, I think, like, since, like, there are people that kind of go through math streams, like, on Twitch, which I'm very surprised about, more often than people look for math content on YouTube, because, like, I think YouTube mainly looks for, like, math content for people to learn math, whilst I think Twitch is like anyone can do math, and they basically do study streams. So yeah, I don't know what I want to do in life. Well, the thing of it is that, like, that happens to everyone, Titan. You know, for me, like, I thought I wanted to be an English teacher in Japan, but I ended up not doing it, but I still majored in English anyway. And then, like, after, like, during my last semester of university, I found my love for math and physics like way late, like in the last semester, but I was already deep in my English major, so I didn't want to change majors. Literally I was about to graduate that semester, so I was like, oh man. So that's when I discovered my love for math and physics. And fortunately I can't stay long. Okay, Romaine Dish, thanks for coming in for a short while. Always appreciate you coming into the chat, and it's nice meeting you. Hopefully we'll see you the next time. Have a good night. You know, like, I was in the same boat, and like, you know, for me, I don't know, it's not like I don't know what I'm doing with my life, because like, I've already, like, you know, worked a full-time job, but now I'm like taking care of my dad at home, and like, I just make content like online, but you know, obviously I am not like, you know, one of those like big content creators like Mr. Beast or anything, but I kind of don't want to get that big, because I just want to be able to like be known to you guys, like connect with an audience that I can genuinely connect with. And you know, like, I have I have two channels, one for my video game channel and this channel. And you know, I feel like you're always gonna discover what you want to do in life, but it doesn't have to be, it's not gonna be at an age where you think you're gonna supposed to figure it out now. Sometimes you just discover it, and you basically know what you do by just doing things. So I would have to say I'm in the same boat as you, but at the same time, it's like, I feel like I'm actually getting closer to like understanding myself better. And I think that's the point of life, is just understanding yourself. And when you understand yourself, like, you know exactly what type of, I guess, like, I don't think of careers, I think of a life, like basically what type of life you want to live. Which is really hard to figure out. I'm not saying it's easy, because I ended up working a full-time job that I didn't really like, but I just worked there for 5 years because I was just, you know, just basically saving up money. And then I just basically found my love for investing, and then I just started investing some of my money. And then after 5 years, I left my job to basically take care of my dad, because my dad's already retired. And my parents were okay with me staying at home, and I was just basically was like, I'm not gonna do nothing while I'm at home taking care of my parents, so I might as well just like use the internet to my advantage and try to make content, even though I'm not gonna make it like, you know, like a full-time job type of thing. It's just basically me just trying to engage with you guys and you know, like, hopefully make a little bit of an impact to your day. Like, you know, like if you're in a rough mood, then I try my best to hear you guys out, or at least read what you type and try to bring, you know, the best out of you. And I think that's what every content creator wants to do for their audience, is just bring the best out of them. And hopefully they're able to like bring out the best within every member of their audience to get them to the best of their potential. Okay, so superposition of electric fields. But pardon me yammering. I was like yammering the whole time. But we did get a good amount of problems done. Well, we did mostly example problems, but I think it's good to actually do example problems along the way. Yeah, this is where it was. Yep. I knew it. Like, when I was doing these type of problems, I realized that I was like screwing up. So I have to remember that nanocoulombs is -9, not -8, not 10 to the -8 power. Okay, so electric calculations. I know comparison kills joy, but when I see my friends have sorted out, I feel devastated. My friend just got into International Math Olympiad. I hope he grows in life, though. Yeah, I mean, yeah, comparison always kills joy, and I agree with that. But the thing of it is that, like, some people might also compare your situation with their situation, and you know, like the worst thing is that you feel bad because it's like, oh, well, you don't have to compare yourself to me. I know you're awesome in your own way. And when you think about it, if the person was honest about their comparison to you, then you can basically say to them, I know like something in life that you have that I don't have. And you know, like it's always going to be that comparison game, and you're always going to find something positive about someone's life that you don't have, but they're always going to find something positive about your life that you have that they don't have. So that's why I feel like we just bring each other up. We bring each other up because like if we're honest with each other, we'll find something positive about one another. Yeah, absolutely. Like, I'm pretty sure your friend, like, that's in an international Olympiad, like, that's a lot of, like, that's, like, very competitive. And that's very intense to do stuff like that, because it's, like, it puts a lot of pressure on you to actually, like, be competitive and, like, succeed in, like, using your mathematical knowledge to the fullest of potential. And for me, I probably can't do that because I'll probably stammer on my words, like when I'm trying to solve a math problem for, like, you know, a competition. Let's see, the total electric field at P is the vector. This is the principle of superposition of electric fields. So we're going to get into superpositions of electric fields. Okay. I'm just going to read a little bit about this before we end stream. Let's see. Combine all the electric charges in the distribution described by the total. So illustration of the principle of superposition in electric field. So we got a charge here that's positive and a charge here that's negative. So the electric field at point P due to the electric charge of the positive charge here. The electric field at P due to charge. The total electric field at E at point P is a vector sum of E1 and E2. No problem, Titan. It was great, like, having you on the YouTube chat. Always appreciate you, and have a good night. Also, like, Titan, if you want to, like, check out our Discord server, it's in the description down below, and there I also have my stream schedule there. And I think my stream schedule is also on the description down below, but if it's not, then I'll put it on for next time. Okay, so we got when charge is distributed along a line over a surface or through a volume, a few additional terms are useful for the line charge distribution. Long, thin, charged. We have lambda represents the linear charge density measured in coulombs per meter. Then we have sigma, which is the surface charge density. And when the charge is distributed, we have rho, which is the volume charge density. Some of the calculations in the following examples may look fairly intricate after you work through the examples. So we will use many of the calculation techniques examples in chapter 28 to calculate magnetic fields and caused by charges in motion. Okay, so I think we're gonna probably end it here, because it looks like there's an example problem like coming up, so I'm gonna save that for like next time. So thank you for joining me today, guys, It's been an awesome stream. For my Twitch chat, if you like math or physics, or you just like a study stream to keep you guys productive, be sure to drop me a follow on Twitch. Most appreciated. Also, I will put our Discord server in the chat along with my Uncle Talks channel. That's my gaming channel, so oh whoops, I didn't mean to do that. I don't know why I typed shout out Discord. Okay, there's the Discord. There's the Discord server. And for anyone on YouTube, thanks for joining us. Please hit the subscribe button if you like math or physics or just a study stream to keep yourselves productive, and hit the like button. And if you're watching this after the live stream airs, you know, hit the leave a comment down below so you can tell me exactly what your mathematical / physics journey is like. In addition, all the links will be in the description down below. Our Discord server, my Twitch channel, as well as my video game Twitch channel. So that's all going to be there in the description down below. And I will be streaming on there tonight. So that's something for you guys to look forward to if you want to check out my video game channel. Okay, guys, that will do it for today. And always remember, I will see you next week. And always remember, deep within yourselves, that everyone is precious. You guys are just as precious as everyone else. And I will see you guys in the next stream. So take care, guys. Bye-bye.